Hey, Clint Mason here, Kaizen Well Solutions. Going to quickly go over the Radial Flow T lubricator, some basic operations, and we'll just go through that. It shouldn't take too long. So first of all, let's talk about the construction of the lubricator. All right. Basically, it's a drop-in design. So that means you just have to remove your existing flow T. This will drop in and fit into that space. All the bypass that you would normally put on a lubricator, maybe it was up here and you got that extra valve and all that line you'd build in, is actually built inside the body. Okay, so that's why we can do it. So it operates exactly the same as a regular lubricator. Has some other advantages, but it operates the same as far as there's an upper outlet. In these ones, there's actually a middle outlet, and then there's a lower outlet built inside that allows the gas to get past the plunger. What these do have is a removable sleeve that allows you a way to force more flow to either the top of the lubricator or more out of the bottom, so you can adjust the flow path or percentage of flow just by either taking the high flow sleeve and flipping it over, which would move the high flow rate from lower area up to the top area. So if you were running a free cycle plunger and you needed more flow rate to push it up for some reason, that's what you would do. In a conventional plunger, you never want to worry about it. You always want the most of the flow out of the bottom of the lubricator section, so when the plunger's in the lubricator, it's not restricting any flow. If we get into a really low rate well, then we have a smaller sleeve that we can put in. Typically, we only put that in as if you're trying to run a free cycle type plunger, and let's say you're under 10 E3 and that plunger was having a hard time coming up and consistently tripping the valve. Then we could reduce the outlet on the bottom section even more, which would force a higher percentage through the top section of the lubricator and around and out. But 99, or well, maybe not 99, but 95% of the time we never have to adjust that. All right. So we can see on the lubricator design, basically what we've got is a Bowen cap on top. Inside that is our spring striker disc. The cap is then held on by a Bowen nut or Acme. It's an Acme thread connection. Here's our upper body. Our upper body is then threaded in using an Acme connection, same as the top, into the T-body. And then the T-body bolts right onto your master valve. And then here's your outlet port or flange. And the gas enters through the sleeve, goes out of these slots, and then goes into a chamber between the sleeve and the flow body, where it allows it to flow back and out. So down and out here. We'll talk a little bit more of that shortly. But those are the basic parts. And then, of course, you've got the catcher that's sitting on the back side here where it shows it. So as the well's flowing, gas is coming up the center, up the tubing. And as it comes up the tubing, it enters the lubricator. There's these upper ports that allow flow to come out through the sleeve and then down. There's actually a set of slots in the mid section, and then there's a lower section that allows the flow. And by adjusting the position, so if we were to flip this sleeve over, for example, I would change the flow percentage, or I would move it from most of the flow out of these lower parts to most of the flow in these upper ports, which would create more flow to pull the plunger up higher if you're having trouble getting it to cycle. And that's basically how it works. Now, if we really are low rate, then we might actually put a smaller ported sleeve in there, where these lower ports would be very restricted, where 90% of your flow would be coming out of this upper and midpoint. So that as the plunger goes by, it's always going to be in the flow. So that's only for real low rates where we need to get that plunger up and cycle a valve. So it's important to know that really looking at for example, here's a standard type of lubricator. You have an upper flow outlet, comes across. You have a connector that goes down your line. You have a lower flow outlet that comes out here. And then you have basically your line. In this case, it's showing this line with this valve closed. So you have an upper outlet, flow crossover, lower outlet, and a combined flow line connection, which is here. Well, we have that as well. Here's our upper outlet, lower outlet. We actually got a midpoint outlet on these. It all is combined inside the lubricator as it all flows down the pipe. Basically, this pipe here is built inside that allows the well to flow, the gas to flow around the outside of the sleeve, and then it comes out into our connector or combined flow line connection through the valve. So all the things are there. The only thing is we don't have these two separate lines. We just build it inside, and we're, I know historically a lot of operations like to pinch back this flow, lower valve to force the plunger up so it's not sitting there bouncing up and down and doing all sorts of things. In our lubricator, because of the way this sleeve is designed, it's not required. The plunger doesn't bounce up and down typically. If you need more flow, we just adjust the sleeve slightly, which is a very simple operation. It takes less than half an hour. I mean, in reality, something like a ball valve or a gate valve should never be open partway closed or partway open. They're all designed to either be open or closed. So doing that is actually creating damage to the valves and equipment anyways, and it could lead to erosional issues and possibly leaks. So this is actually a better system. And because of the way we flow, we get very low pressure drop when that, even when that plunger's in that lubricator. It's very low, lower than you'll get across a regular lubricator, just because of how the plunger is able to sit in the sleeve and the way the flow can go around the plunger on all sides, and it doesn't have just a single port here and a single port there. So it's usually a very simple drop it in, don't have to do a bunch of adjustment, and away it goes. And like I said, probably 90 or 95% of the lubricators we put in, we just use our high flow sleeve in the position that gives you the highest flow rates, which is typically the higher flow rate out the bottom, second flow rate here, and a third flow rate here, so that, and that's the way we would usually set them up. So for a conventional plunger or a high rate free cycle, we might flip that sleeve over if we have a medium rate flow path. So, and then here's just an example. Now this is my flow block with flow T, but you can see we can, you know, with the small sleeve, you can see the flow percentage. Now the small sleeve, even though the flow percentage is 98% here and 66% here and 26% here, if I was to flip this over, it would be 98, in this case 26 and 6, which is really going to push all the flow up. If I have the large sleeve, it's 33, 22, and 45. Now, in this particular case, you can see in this example, if we were flowing at 2100 kPa at 20 E3, if I had this low pressure, the low flow sleeve in there, I would probably have about a 0.8 psi pressure drop across there. But the high flow rate, there's almost no pressure drop across there. And when the plunger comes in, it does start to block some of these upper flow paths or restrict them. So you would see a very small pressure drop. But that pressure drop is typically just the pressure required to keep the plunger in the lubricator. So it's usually under 3 psi or even 2 psi, even at very high rates. We get a very clean flow path with very little restriction. So adjusting the flow distribution. Now again, when they come out, they're going to come out in the high flow rate condition. It's really very unlikely you even have to adjust it. If you got a conventional lubricator, you always want to leave it in the high flow rate so you're not creating any restriction when that plunger's in the lubricator. Lots of flow below it. If you put it in the medium high rate, the more flow is up high, which means that the gas has to flow past the plunger versus just flowing up underneath it and out, which will cause a little more restriction. So that's why we always leave it in that high rate. And the radial lubricators have a sleeve that is designed to create the required flow restriction depending on the type of plunger and the rate it's flowing at. Typically there are two sleeve choices. Again, I've talked about high rate and low rate. The high rate position is designed to allow a conventional plunger or a high flow rate free cycle plunger to operate. Medium high rate, which is just basically taking that high rate sleeve and flipping it over. And that's what we would use for free cycles, not for conventionals, just free cycles. Medium rate is for a conventional free cycle plunger under 10 E3, and then low rate is when we're really flowing these wells really low, where we have a really high pressure where you're not getting much velocity, and you need to force more gas up to the top of the lubricator to ensure that plunger always comes up and trips the valve. Again, if you're running a conventional plunger, this high rate design is where it should be. Probably 90% of your free cycle plungers will operate in this, and then we just start doing this as the rates get lower, and we need to force a little more gas past the plunger to support it and keep it up there. So adjusting the sleeve is pretty simple. Depressure the lubricator, we remove the set screws that are on the side of the flow T regulator, or lubricator I mean, and then you basically use a strap wrench, and the top section just threads out. It's just a bone connection, same as the bones that are on the top. It's a bone into the body. It's a clockwise turning. You turn it clockwise to unthread it, where the top bone you turn counterclockwise to unthread it. Okay, designed that for a specific reason. But you usually use a strap wrench. We just put it on there. Once you've taken those lock pins out, it should just thread out with a little bit of force, and once it starts turning, it should spin out easy. Then we would flip the sleeve or add this low flow sleeve. If you use a pipe wrench on the body to take it apart, of course you're going to damage the paint. It's going to look crappy, whereas strap wrench really doesn't do anything, and it never should be that tight that you require anything more than a strap wrench. Anyways, once you've removed the body, flip the sleeve, done that, whatever, inspect the O-rings, thread the body back in to the flow T, and basically you spin it down and just snug it up a little bit. You don't have to go crazy on it. And then you replace those set screws. I always put a little bit of blue Loctite, not red, blue Loctite, because that basically just makes sure that they're never going to come loose unless you want them loose. And reassemble the top cap. Slowly pressure up the lubricator, watching for any leaks, and then just put bleed everything off, and I'll put the plunger and well back into service once I've confirmed all that. Now basically we can also do that same thing when we're because when we're operating this lubricator and the flow path design, there's really no reason to ever try to restrict that outlet. Okay, all the flow, all the control is done inside the lubricator, so there's nothing for you to do outside of that. The plunger will find its sweet spot. They typically don't sit there and bounce more than maybe once or twice in the beginning when they first show up, but they will find and it all has to do with the flow path in that sleeve and the multiple exit points and the percentage of flow that we have in there. So there's really very little you need to do. So even if there's a little bit of bounce because of the design, there's really no significant increase of wear to the lubricator. And the only wear item in this lubricator really is a sleeve, which can be easily replaced if for some reason, 7 years down the road or 5 years down the road, we started to see some erosion or some wear. We could just pop that out, and it's a low cost item, and replace it. The other thing is to stress is all functions of this lubricator operate the same as any typical plunger lift lubricator. Okay, catcher works the same, bow and top's the same. The striker disc, the spring, everything we use is the same in all of our lubricators, whether it's a flow T, flow block, or conventional style lubricator. All proven designs, they all work. Okay, I only recommend, I guess one thing is you probably are going to require a plunger pulling tool, a magnet to pull the plunger from the lubricator. It's pretty normal for most of the bow and top lubricators because it's hard to get that fishneck up. It stays down in the body a little bit, so you need something to reach in and pull it out. I recommend that the lubricators get inspected maybe one time per year, which would include removal of the upper body only. You don't have to take the flow block or flow T section off. We just pop the upper body off. We go in there, we inspect all the internals, make sure we're not seeing any unusual wear, make sure we're not getting a buildup of some product or scale or something that could be causing a problem in the future. Then we'll inspect the unit, grease where it needs to be, O-ring replacements if it needs it. And again, there's no reason to remove that lower T section. You can, once you take that upper section off, you can see the entire thing. You can see if there's any corrosion or anything going on that's unusual. So it's on. It's just like any flow T, except that once we take that top out, you can really see what's going on inside it. So anyways, once that upper section is removed, all you need to do is grease it, get everything ready, put it back together, and put it back in service. It's probably, like I said, somewhere around a half an hour job, 20 minutes to a half an hour to do this, and do an inspection. And basically it's put back together, do a quick, make sure when you pressure it up that there's no leaks or anything, but it's an O-ring seal on everything you're touching. It's not like retorquing bolts or flanges. It's just put together, and it should pressure test, and away you go. And that's basically it. That's the operation of the lubricator. That's how it works. Just remember, it really works very similar to a conventional lubricator. So you don't have to, don't worry, except you don't have to worry about, pinching that lower flow, which is really not a very effective way of operating these wells anyways. If you have any other questions, reach out to us at info@kaizenws.com. Or any one of our field staff, or the PCS Ferguson field staff, if they supplied you with this product, they can help you out as well. But hopefully you have enjoyed this video and help explain a little bit on how it works. And if you have any questions, just again, reach out to us. Have a great day. Thank you.